Nanotechnology has been developed for 2 decades, but its wave of application is only now beginning to break. It will make the computer revolution look like small change. It will affect everything from the batteries we use, the pants we wear, to the way we treat cancer. Nano is the unit of length. How small is 1 nano? 1 nano equals 1/1000th of a meter, which is almost the length of a beard grown during the time when a man takes a shaver from the table to his face. Nano is really small. It is so small that you can hardly imagine. Take human being as the standard. How small is 1/1000th of a meter? Let's start from a girl of 1 meter tall and look at the gradually shrinking world in the ratio of 1/10. Her small hand is the size of 1/10 of a meter. The size of 1/100th of a meter is the skin surface. 1/1000th of a meter can see the smaller parts of the skin surface. 1/10,000th of a meter gives us the view of the cells of the body. 100,000th of a meter shows us the chromosome. 1/1000th of a meter reveals the fabric of chromosome. 1/10,000,000th of a meter, that is 100 nanometers, displays the structures of the fabric of chromosome. 100 millionth of a meter, that is 10 nanometers, exhibits the double helix of DNA. 1/1000th of a meter, that is 1 nanometer, can see the molecular structure of DNA. Though nanometer is very small, many phenomena of matter will not happen unless they reach nanoscale. For example, the red color of sky at sunset, the navigating ability of birds, and the lotus effect of lotus leaves, and so on. Nanoscience refers to the study of the properties of materials on the nanoscale. Nanotechnology is the technology operating on the nanoscale. We can only see objects of size no less than 200 nanometers under the optical microscope. The resolution of optical microscope is not enough for nanotechnology because it requires the ability to peep or manipulate materials in nanoscale. With the discovery of electrons in the 19th century, we have a clearer picture of the phenomena that occur in the atomic scale. However, quite a number of phenomena cannot be explained with classical concepts. A new branch of physics called quantum mechanics was evolved to deal with physical phenomena at atomic scale. According to quantum mechanics, electrons do not only behave as particles, but also behave as waves. The dual properties of electrons led to the development of a new kind of microscope called transmission electron microscope. The resolution of our microscope can reach 1.02 Armstrong. It can be adjusted to see the structure of a hydrogen atom. A transmission electron microscope is divided into 2 parts: an electron gun and the magnetic lens system. When the cathode is heated, it emits electrons. The electrons are accelerated by the high electric potential of the anode. The electrons are then focused by the magnetic condenser lens so that a unidirectional electron beam is formed. The electron beam is directed onto the object being observed, and the transmitted electrons record the details of the object. The transmitted beam is further deflected by the objective lens and projection lens to magnify the image. Put the sample into the TEM first. A valve will then be opened. Electrons will be projected on the screen from the electron gun. Electrons cannot be seen by the naked eye, but the image is produced on the fluorescent screen. The basic structure of an electron microscope and an optical microscope is quite similar. We use the magnetic field to focus the electrons to form an image. There is a camera under the screen. If the screen is lifted up, the camera catches the image on the screen. Generally speaking, nanomaterials refer to materials with dimension of size between 1 to 100 nm. Nanomaterials can exist in different forms, and each form has different shapes and structures. Examples are nanowire, nanotube, and nanoparticle. Nanotechnology matters because familiar materials begin to develop odd properties when they become nano-size. Although not all materials change their physical properties when they become nano-size, but if some do, it will be a boom. Scientists can engineer heaps of exotic new materials, such as transparent materials that can conduct electricity and glue them with high thermal conductivity. It is like you shrink a cat, and it keeps shrinking it, and then at some point it turns into a dog. Why do changes occur when the materials reach nano size? When an object is subdivided into smaller and smaller pieces, the ratio of total surface area to volume will increase. For example, the dimension of a cube is A. Its total surface area is 6a squared. If it is subdivided into 8 small cubes, each with a side length of half a, then its total surface area is 12a squared. In other words, the smaller the cube we divide, the ratio of total surface area to volume becomes bigger. It is just like the color of bulk gold is bright yellow. If we subdivide 1 gram of gold into grains of size smaller than 100 nm, the color of the nano gold will become ruby red. This is because the nano gold atoms on the surface interact with incident light differently from that in the bulk. The increase in surface area will increase the rate of chemical reaction, the ability of absorption, and the catalytic action. Nano gold is a good catalyst, while gold is very stable at normal condition. Since the ratio of surface area to the volume of nanomaterials is enormous, structures which usually are not stable under normal condition can be stable at nanoscale. Carbon is one of the such materials that possess this kind of characteristic. The usual forms of carbon are graphite and diamond. Diamond consists of huge atomic networks formed by carbon atoms. Each carbon atom is chemically bonded to 4 atoms to form a tetrahedral structure. Diamond is the toughest mineral. Graphite consists of layers of carbon atom with hexagonal rings. Carbon atoms in the hexagonal rings are bonded strongly with one another, but the layers are held weakly together, making it easy to be pulled apart. We only knew that carbon only includes graphite formed by carbon atoms layered in flat surface and diamond formed by carbon atoms in tetrahedral structure until the discovery of C60 in the 80s of the last century. C60 is a closed structure composed of 60 carbon atoms arranged in the form of a hollow ball, usually called buckyball. Its structure is exactly the same as a football, a combination of 20 hexagons and 12 pentagons. Apart from C60, C70, C76, C78, C82 have subsequently been discovered. These spherical shells of carbon are called fullerene. In 1991, scientists discovered another structure of carbon, nanotube. Inside the bottle is some carbon powder. But if we look at it closely, the needle-shaped conglomerations is not ordinary carbon powder, but carbon nanotubes. Beside arranging in spherical shape, carbon atoms can be arranged in many other ways to produce other forms of carbon. Carbon nanotubes are hollow tubes made of carbon. A single-walled carbon looks like a seamless steel cylinder. It is rolled from a single atomic layer of graphite sheet with a diameter ranging from 1/10 of a nanometer to few 10 nanometers. Multi-walled carbon nanotubes are rolled from a few layers of graphite sheets, forming a concentric cylinder. In fact, the structure of a carbon nanotube is similar to a pile of paper, rolling to form a tube. We are now looking at the structure of a carbon nanotube. When you magnify it many times, layers of carbon structures can be seen. If you magnify it even larger, you can see a black line which is actually a layer of carbon atoms. The distance between two layers of carbon is about 0.3 or 0.4 nm. Nanotubes are not only special in their shapes, their physical properties are also very interesting. Carbon nanotubes have variable conductivity. Depending on the rolling direction of the graphite sheet and the diameter of the formed tube, it is interesting to find that a single-walled carbon nanotube can be a conductor or a semiconductor, just as copper is a metal itself and rubber is an insulator which cannot conduct electricity. Nanotube only contains carbon, but it can sometimes turn into metal and sometimes turn into semiconductor according to the rolling direction and the diameter of the graphite sheet. This cannot be found in ordinary materials. Carbon nanotube is the thinnest material that can be found till today. Though it is very thin, its mechanical strength is 50 to 100 times stronger, but its weight is just 1/6 of steel. Because of their light, stiff composition, the tubes have also begun turning up in high-end sporting equipment such as bike handlebars and golf club shafts. The application of nanotubes on screen display is one of the key researches in recent years. Cathode ray tube uses electron guns to emit electrons. When the electrons emitted from the electron gun hit the fluorescent screen, an image is formed. The electrons are deflected by the magnetic field to reach different positions on the screen. Since electrons are moving at high speed, the displays are often occupying a huge volume. Carbon nanotubes can emit electrons even at low voltages. When connected to a voltage, an intense electric field will be set up near the sharp point and electrons will be emitted. This process is called field electron emission. In nano size and diameter, the extremely small nanotubes, which act as an electrode, will stand up when a low voltage is applied. Electrons will be emitted from the tubes because of the field emission. The electrons, after regulated by the grids, will hit the fluorescent screen to form an image. As compared with a traditional CRT display, the electron gun is replaced by groups of carbon nanotubes gun that can emit electrons at low voltage. The thickness of the field emission display can then be much reduced. In addition, they consume less power and so they are energy efficient. Therefore, FED can be the new generation screen display.
Since nanotechnology can produce transparent cells, we can have transparent mobile phone thereafter. Transparent tablet computer will no longer be a myth. This is a transparent anode. This is a transparent cathode. Traditional battery is divided into 3 parts: anode, cathode, and electrolyte. Nanotechnology can make traditional cell materials into nanoscale. The scale cannot be resolved by naked eyes. In the design of the battery, the electromaterials are coated on the transparent substrate by a specially designed arrangement. The electrodes produced are considered to be transparent. The biggest disadvantage of light-emitting diode is that they are very sensitive to heat. When the chip is working, the temperature goes up easily and causing serious light failure problem, shorten the lifespan of light-emitting diode. We research and develop nanoglue. Nanoglue can make light-emitting diode radiate the heat produced when LED operating, reduce the loss of energy, will also increase the brightness, and also extend the lifespan of light-emitting diode.